Hi, good evening, everyone. Am I audible? Anyone please confirm, am I audible?
Yes, sir, you are.
Okay. So I think we should wait for some minutes to others to join, and then we will start. Okay, so I think we should start now. Uh, as you know, this session is solve with the session, and last time, due to power cut, the session got ended in between the discussion. So my plan was to discuss the collab file that sir has used on KNN. So, so in this session, we will cover that collab file as well. So first, we will cover the solve with session because it will help us to understand the collab that sir has used, because most of the definition, most of the functions are all taken from that collab file notebook. Okay, so let us start now. Okay. So as you know, in this session we will do code. So you are supposed to open your collab file, and this is your first task there. You have to generate data before doing modeling on KNN. So in this session we will do the KNN algorithm. We'll apply KNN algorithm on the classification data set, and we'll see how we can apply the same kind of functions and same kind of algorithm to regressions as well. So here we will see KNN algorithm, and then we'll see a validation set, how to validate the data set as well. Okay, so before applying the model, we will generate the data set. And so first you are supposed to import the libraries NumPy and Matplotlib, and then generate the data. So in the data set, for generating the data set, you can make use of the API make blocks, and that API is contained in sklearn.datasets, where you have to generate data set of 100 samples with two features. And so there are 100 samples, 50 in the one class, 50 in the another class. So all these classes would be centered at 0, 0 and 5, 5. And the standard deviations of those classes are 3. And you have to set the random state to 42 to make sure that every time you run this code, you get the same data set. Okay, so this is your first task. Take your time and let me know once you are finished. You are done. Okay, so I think we should discuss the solution now. So this part is very easy. You must have done this before. So, so first let me import the libraries. So these two libraries we are going to use, NumPy and matplotlib. Okay. Next thing is that we have to generate data using the API MacLog. So this API is contained in the module called sklearn.dataset. So if you have done, if you are enrolled in MLT, so you know this. If you are not enrolled in sklearn, so nothing to worry about. It's just a module in the sklearn libraries, sklearn.datasets. Okay, so I'm to import make logs only. So from sklearn.dataset, I can import make logs, right? Okay, so try to make log. So how this work? You have to set the centers for the you have to set the centers for the clusters, right? So how many clusters you want, depending upon that, you can set the centers for those clusters. So we have to generate two classes, one centered at 0, 0 and another centered at 5, 5. So we can set the centers at one at 0, 0 and another at 5, 5, right? So this will be our centers, and here we can also set number of features. How many features we want to use? So remember, here we are using center 0, 0, 5, 5. It means we are using two features. So x coordinate here is first feature. Another y coordinate here is the second feature. So we actually we are using two features here that we can set using n features equal to 2. Now also we have to use standard deviations of 3. Okay, so how many samples we have to use? That we also can set. We have to generate 100 samples. So we can use n samples equal to 100 and standard deviation. So that for that we have cluster standard deviations, and this value we have to set 3. And always remember, whenever you are using any like any estimator or any functions from sklearn library, always set random state. Okay, so it makes sure that whenever you rerun this code, your data set it generates the same data set. Okay, so if you notice here, this generates tuple here. So first are the first are your training data set, and the next value in the tuple is your labels. Okay, so you can take these separately by calling the variables name x and y. So in this tuple, I can call x as my data set and y as my labels. Okay, so x will be my now data set and y will be my label. You can check this as well. So checking, let's say x dot shape. So what will be the shape of x?
100,2.
100,2. Okay, because we have 100 samples and 2 features. So shape of x will be 100,2, and similarly y dot shape will be
Only 100.
100, right? It's a flatten. It's the only row vector with 100 samples, right? And let's see what are your what are your examples in this. So let's print first 5 examples. So these are your first 5 examples, and if we also print their labels. So look, so first examples is at centered at 6,4. I mean 6.4 and 4.7, and it belongs to class 1, right? And another is situated at -2, -0.9. So it's coming from class 0. So it's So first example is centered is coming from the cluster 1, which is centered at 5,5. So the cluster which are centered at 5,5 are actually belonging to class 1, and the cluster which are centered at 0,0 are belonging to class 0. So we have two classes, class 1 and class 0, right? So now we have data set with us. Okay. So any problem up to here? Now we need to create a 2D plot for this data set. So take some time and plot the scatter plot for X data set here, just to visualize our data set, how they are distributed in the input space. Yes, so that is the right code. Let's see how to do that. So remember, we have to do scatter plot for that. Okay, so we can do it here. So what is the functions for that? We have plt.scatter. So what will be the on x-axis? We have to provide the features on x-axis and another features on the y-axis. So in the x-axis, first row denotes your first feature, right? So we will take all the examples, I mean all the rows, but with only first feature, that is first column. And on the y-axis, what will be there? And that will, again will be the all the examples, but with the second feature, right? So second feature are first column, all the examples with the first column. So these are my data set. This is my first features and this is my second features, and I'm taking all the examples, right? So if I plot this, so this is how our data set looks like, but we have to differentiate between two classes, two clusters. So for that we can set the C as equal as by. So it will color these points as by. So a by has two classes, 1 and 0. So all that belongs to class 1. It will color with one color, and the next that belongs to class 0. It will color it with the different color, right? So if you see it now, so this is how your data set will look like. So you can also set the size as well. So size, for setting size, you can set as equal to, let's say, 200. So and also we can set figure size as well. So plt dot figure fixed size, right? We can set at 10,10. So now if you see that, this is how your data set is looking like, right? So if you see here in the middle, there's no very smooth, there's no that separating hyperplane that can divide those data set, because in the center they are mixed type of classes are distributed here. So it will be good to see how to apply KNN for the new example which belongs to center of these two classes, right? That we are gonna see, and another we can also set here alpha. Alpha is that opacity will be set. So if you set it will equal to 0 point something, so this data point will be transparent, right? So that we don't want, we want to set it close to 1. Let's set it plus 1 itself. So this is how they will look like. And edge color also you can set. Okay, so rather than setting edge color, we can set the style here. We can set PLT dot. What is that style, right? Style set style use. Here I can use C1. Yeah. Now it's looking better. So on the x-axis we have one feature, and on the y-axis we have another feature. So of course these bytes are not looking good. So we can set the edge color here. Color equal to, let's say, K. Okay. So now this data set is looking like this. Now we have to find KNN algorithm for this, right? So up to here, any doubt, any questions?
So I didn't understand C equals to Y.
C equal to Y. Okay, so what's happening there? If you don't set C equal to Y, then all those data point will be colored with will be in the same color, right? So we want to differentiate between two classes, class 1 and class 0. So what C equal to Y, when we set C equal to Y, so what will happen? Which of those example which belongs to class 1, so it will check in the Y. The Y has two entries, 1 and 0. So which example belongs to class 1, it will color with the black, and another which belongs to class 0, it will color it with some different color. So now it is using two different color. Yellow, sorry, black and white. You can also set the different colors as well by using CMap. So CMap also takes, you can set counts. I don't know what are the different. Okay, we have a mess, right? Blues, maybe blues will put. Yeah. So now it will color it with the blue and white. And
So, like, how will we know that white one is class 0 or class 1?
sorry.
Like, how do we know that white one belongs to class 1 or class 0? Like, how do we differentiate? Can we write in the graph that yellow belongs to class 0 and blue belongs to class 1?
No. By looking at the data set, we come to know that which belongs which data set which is centered at 5,5 are belongs to class 1, and the examples which are centered at 0,0 are belongs to class 0. Look at these values. We have taken 5 examples and their corresponding labels. Okay, so if you check it here, so first example definitely comes from the center 5,5, right? And its label is 1. So we can looking at the data set, we can see that these yellows are coming from class 1, and these blue or whatever color is violet, this data set are coming from class 0.
But still, like, it cannot show on the graph.
We can annotate that.
So how?
Sorry.
So, like, how to annotate?
For that we have the function plt.annotate. Okay, you can check that annotate is a function. Just give me 1 minute. You have a function called plt.annotate. So this is how it looks. You have to set here plt.annotate, right? So what you have to annotate that you set by using the parameter s, right? So s is the depreciated synonym for this parameter, the text of the annotation, right? And at which point you want to set that that also you can set using the parameter xy. So this is the function in the matplotlib for annotating. Okay. So this part was very easy. We have generated our data set now, and data set is looking something like this. Now we have to use So now we have to apply KNN, okay, on this data set. So before applying the data set, remember in the KNN what happens, we take k nearest neighbors. So neighbors, for finding neighbors, we define some similarity measures. Here we can apply Euclidean distance or Manhattan distance. So finding that, first we have to define a function. So we have to define a function which measures the distance between 2 points. Okay, and the points are given as vectors m of the size m. I mean the column vector. Okay, so you have to define a function called distance. It takes 3 parameters: x1 the first point, x2 the second point, and q equal to 2. So here q equal to, make sure that it is Euclidean, and q equal to 1 will be the Manhattan distance. So by default, this function calculates the Euclidean distance. So q equal to, actually we are finding the LK norms. Okay, so which norm we are finding, we can set using K. So L1 norm is Manhattan distance, L2 norm is Euclidean distance. So these are of most used. By setting different values, you can get different distance, different values of for distance. Okay, so this function you have to define. So take some time and define this function. So if any doubts regarding this, you can ask.
So Euclidean distance is just the square root of the sum of the individual points. Sorry, the square root of the squares of the individual points. That's the Euclidean distance, right? The difference.
Yeah, square root of the sum of squares of those corresponding difference.
Yeah, and Manhattan distance. I mean, I didn't see the lecture, so I must have.
Manhattan distance is the sum of absolute values. So absolute values is absolute difference of those corresponding values, and then take the absolute sum.
Okay, no square root, nothing, just the
No,
sum.
nothing.
Okay.
Okay, so anyone has defined this function? Okay. So most of you have done by setting if key is equal to 1 or if q equal to 1 or q equal to 2, right? There is a better way to do that. What if I'm to find LK norm? Then will you set different q values there? Let's say this function will give you all the norms. All norms mean L norms. So L1 norm, L2 norm, L3 norms, all such norms this function should return. Right. Then there is a better way to define this function rather than saying that if this happen, if q is equal to this or q is equal to that. Right. So there is a better way. So remember in the LK norm, what happens? We just take element wise. I mean the that coordinate wise difference. Then we raise to power k, then we'll sum all those terminologies, and then the overall will be raised to power 1 by k, right? So that definition we are going to use here. So let's define this function def distance. Okay, so it takes 3 parameter x1, x2 and q, and whose the default value for q is 2. Okay, so what would be what it should return? It should return, first we will take the difference of those x1 and x2. Remember, x1 and x2 are what? These are the vectors. So the vector subtraction will take place. So every rows will be subtracted, and it will return the vector of the same shape, right? It's just matrix subtractions, right? And these values will be raised by power q. So these value will be raised by power q. Okay, and then what? Okay, we can do one more thing. We can take absolute value first, just to make sure that if it's q equal to 1, it takes the absolute value, and if the square, it doesn't affect the values. np dot absolute, right? So first we can take absolute values and then raise to power q. Okay, now what we are to do? We are to take sum, right? So for that we have the function mp dot sum. So by finding sum, we can find the sum, and on the x is 0. So why we are doing this? And raised to power what? 1 by q, right? 1 by q. Okay. So this is clear. Okay, let's take one example to understand what's actually happening here. So let's set x equal to np dot array. So let's take 2 by 2 matrix. So let's say 2, 3 and 4, 5. Right. Now take any other point y equal to np dot array. The same matrix we can take as 2, 2. 2 by 2 matrix. So let's set 4, 5 and 7, 8. Okay. Now we have two matrices. Can we subtract those? What will be the shape of x minus y? What will be the outcome for x minus y?
2 by 2.
2 by 2. Is it valid operation? It's a matrix subtraction, right? So how the subtraction will take place?
Element wise,
right? So 2 minus 4, 3 minus 5, 4 minus 7, 5 minus 8, right? So let's check it. Right. So 2 minus 4 minus 2, 3 minus 5, 4 minus 7, and 5 minus 8. So this is working fine. Now, so what's now we have taken the subtractions. We can take absolute values as well, just to make sure if there is we are finding the L1 norm, then it takes the absolute value for that. Now this will be the absolute values. What we have to do? We have to raise to power q, right? So what is Q here? If we are finding that, let's say we are finding Euclidean distance, so we can set Q equal to 2. Okay, so all these values will be square wrapped. Now we have to take sum, right? So NP dot sum, and we will take sum along the x is equal to 0. So now what will be the output of this? What will be the shape of this output?
One comma 2.
1 by 2.
1 by 2. Okay. Why this? Why that is? Because we have set x is equal to 0. So every columns will be added up. So 4 plus 9 will be added up, and we will get 13, 13, right? And next part, just we have to take raised to power 1 by q. Okay, q is 2 here. Yeah. So this is how you find the distances. Is that clear? Okay.
So
What if
x is equal to 0 or 1, that is still confusing.
Okay, so actually why we are setting this will see in the next part. So actually what's happened in our case, we have data set. In data set we have more than 1 points, right? In the data set we have 100 points, and we will for a new point, we will calculate the distance of that new point from all those 100 points, right? So what we will do, we will set those points on the along the columns, and then we'll take the distance from that new point. So every column will give, in that case, every column will give you the distance of that new point from every example, right? Otherwise, you have to take care of all such points. You have to accept every point, and then you have to find the distance. That we don't want. What we want to collect all the examples in one matrix, and then we will find the distance of that new point from every examples from that matrix, right? So for doing that, we are setting every examples along the axis, row axis, and then by setting x is equal to 0, it makes sure that it add row wise, so that every column will give you the distance of the new point from all those examples. That's why we are doing this.
Sir, in this case, then we are actually finding the distance between 2,3 and 4,5 and 4,5 and
4,5,
7,8.
yeah, exactly.
And it just so happens that the distance is the same in this case.
Yeah. Right?
Okay, but actually in the real example, you will have only one y, right? Or when you say y, I mean, I'm assuming that there's one new point.
Yeah, only
trying
one
to
new
find.
point here. Yeah.
And
so
we're looking at multiple x.
So that's
points.
point I'm to make sure here. So here x and y are of the same dimension, right? 2 cross 2, 2 cross 2. So here x by x minus y makes sense, because it's a metric. Algebra says that if we are subtracting two metrics, they should be in the same dimension. Let's say what if they are not in the same dimension? Let's say this the shape of this is, shape of x is 2 cross 1, and the shape of y is 4, 5 and 7, 8. Does this expression make sense now? Can we subtract x to x minus y?
Will not broadcast.
Actually, matrix algebra says that you cannot subtract these two matrices, because the dimensions are different. This dimension is 2 cross 1, and this dimension, the dimension of x is 1 cross 2, right? And the shape of y is 2 cross 2. So we cannot subtract this by matrix algebra. But the NumPy has the features. Actually, the feature is called broadcasting. It broadcast means it brings those matrices into the same shape, same dimension, and then subtract. So what will happen here? This subtraction will take place. So actually, what's happening here? This is only one row. Okay, and in the by there are two rows. So what it will just duplicate these rows to make sure there are two more rows. So 2, 3, and it will automatically set another rows to 2, 3. It will just duplicate this thing, and then subtraction will take place, right? So if another row is 2, 3, then what will be this distance? Okay, so we can find out x minus y here. right now look at 2 minus 4, 3 minus 5. So next row will be again 2 comma 3. So 2 comma 7, 2 minus 7, and 2 minus 8. Sorry, 3 minus 8. So that's how broadcasting works in the case of numpy. So even x and y are of not the same shape, numpy makes sure that they comes into the same dimensions, and then the broadcasting takes place. What if it's a row column vector? Let's say this is a column vector now.
Expand that.
What will be the output of x minus 1?
It will be an error.
Can broadcasting happen? Shape of x is now 2 cross 1, right?
No, sir. Broadcasting will not happen here.
Think again. The shape of x is 2 cross 1, and shape of y is 2 cross 2. Can be in the shape of can be extended to the shape of 2 cross 2? Just duplicate the columns. Duplicate the values of the columns. So you have two in the first row, 3 in the second row. So second column, it will just duplicate. In the second column, the first row will be 2 and the second row will be 3. So it just will duplicate the values and the subtraction will take place. This, right? So we can bring x into the shape of y. If it is, we can expand the shape or dimensions to bring into the same shape, same dimension. Then the subtraction will happen.
Sir, how this happens, sir? I can't understand.
So here x is of the shape 2 cross 2. So let me explain this by using the right tool. Okay. So actually, if you notice there, so x is of the shape 2 comma 3. So this is 2 cross 1, right? And y is of the shape something 2 cross 2. So let's say 4 comma whatever the values are, 4 comma 7, 5 comma 8. Right? So what it will do, it will expand this dimension to bring into the same dimension. So here it will duplicate these values. So it will duplicate 2 comma 2, 3 comma 3, and y is the same. So now subtraction will take place.
When will it not happen? So sometime in some cases you'll have to expand the dimensions, right?
Yeah. So let's say x is of 2 cross 3, right? And y is of the shape 3 cross 2. So let's say 4 comma 5, 7 comma 8, and some other row 9 comma 2. Okay. Now x can be expanded? Now check it on the polar file. Let's say your y is now one more row. Let's say 9 comma 0. Now can x minus y take place? It shows error. Operand could not be broadcast. Why? Well, look at the shape of x and y now. So x has the shape 2 cross 1, and y has the shape 3 cross 2, right? So either it will make copies of rows or columns, right? So if it will make copy of rows, then 2 comma 2, 3 comma 3, 3 comma 3, such copies it can make. But again, you can bring the same number of columns. But what about rows? It has one extra row as well. In this case, this broadcasting will not happen. Okay.
So, sir, x can be 2 cross 2 or 3 cross 2. Sir, 3 cross 2. This one.
So it can be 2 cross. It can be 2 cross anything, but the rows will be 2. So it can be 2 cross 4, 2 cross 5, anything. It will just make copies 2 cross 3, 2 cross 3, 2 cross 3. It can make copies, but if you have make copy along with this rows, if you are making copies of this column, then it will make copies of column only. Now it won't make the copy of the row. Okay, so it is in 2 comma 3. So it will make the copy of this thing, so 2 comma 3. Now y has the shape 4, 7, 9, 3, 8, 2, whatever that is. So this row, it will not be added anyhow. It is X. That's why the broadcasting will not happen.
Okay, sir. Okay.
Okay. Okay. So this will be more clear when we will apply this subtraction or this definition of function in our data set. Okay. So here we can remove this row, then can apply. Yeah. Okay. So this should be clear. This function definition should this function definition is clear now?
Yes, sir.
Yes,
Yes.
sir.
Okay. So now we can move to the next task. Okay. Now we have to compute a distance, Euclidean distance q equal to 2 from all the data points, and the new point is 0,5. Okay, so you have to find the distance from all the data points in X. Okay.
Here the K is the norm, is it?
Sorry, Q is the norm.
K,
Q
K.
equal
Oh, no, in this predict function that you've got different parameters, right? Here. Oh, okay, okay. We are actually trying to solve the previous one, task 3.
task 3.
Okay.
Okay, once you have found the distance from every data point, you can also find the closest point to that data set, to the point 0,5. Okay, so I think we should discuss the solution now. So how you will find this?
Is it the minimum argument using argument minimum of the distance?
Okay, that we can do, but how you will find the distance of that point from every data set, every points in that data set. So
With
first,
the
let's say
loop,
the
it's possible, but yeah.
no, without loop also you can do. So first, let's set the point. The point is 0,5, and we can reshape it to 2,1. Okay. 2,1 or 2,1. So if you notice, 0,5 will be here somewhere. So it is 0 and 5 here. So that point will be here somewhere around this point. Okay, so we deliberately chosen this point because for different value of k, the prediction will be different, right? If you choose k equal to 1, so it may be that the purple color, or if you choose k equal to 2, so maybe tie will happen, or if you choose k equal to 3, it may predict to be in the yellow class, right? So we have chosen this point deliberately to see the behavior before different values of k. Okay, so first we will find the distance from every data set. So we have set the point 0,5, and we have reshaped it to 2,1, 2,-1. Okay, because here it is a row vector, we have come into the column vector. Okay, so now we will make the distance function. We'll use the make use of distance function. So distance function, distance between new point and the x. Will it work? Now check the shape of x and new point on data set. What is the shape of new point? It is 2,1. What is the shape of x?
100,2.
So can this operation will be valid? That subtraction of operation will be valid? So let me say again. Let me show this. This part should be clear. Otherwise, that may be confusing how the operation is taking place. Okay. So x, the new point. Let's say the small x. Small is of the shape 2, 0,5, right? 0,5. Now x has the shape 100 cross 2. So 100 cross 2 means you have 100 examples and 2 rows, 2 columns, right? So 100 cross 2. So each row denotes example, and each column denotes their corresponding features, right? Now what we have to find. Let's say the examples are x1, x2, or say k1, k2, something like that. So what we have to find? We have to find x1 minus 0 square plus x2 minus 5 square. This is the distance of this point from this first example. What will be the distance from the second example? This will be k1 minus 0 square plus k2 minus what's happening? K2 minus 5 square, something like that. So we have to do this, right? And remember the distance function now. So what distance function do is just take the sum column by. So what we can do, we can just take the transpose of this thing, right? So x transpose will be what? Now this will be of the shape 2 cross 100, right? And each features will come in the columns. So in the first column, this will be the features of first example. In the second column, the features of the second examples, right? And this distance function is working like that. So it will do x1 minus 0 if we apply the distance function. Remember this is what happening in the distance function. Okay, so this is distance function will calculate, and now broadcasting can happen because this is of the shape 2 cross 1, and this is the shape 2 cross 100. So it will expand the dimension of this to the 2 cross 100. So what will happen actually? So 100 copies will make. So 0,5, 0,5, such 100 copy will make, and corresponding column wise distance will be calculated. So in this way, we can find the distance of new point with every data sets. Every points in the data set.
Sir, initially itself we can make x as instead of 2 by 1, can we make it as 1 by 2 so that it will match with 100 by 2?
Then on the distance function you have to set x is equal to 1.
Okay.
Okay, so you have to make sure what you are in the, if you, in the distance definitions you have set x is equal to 1, then you have to make sure that it comes in the shape 1 cross 2, and this this is 100 cross 2. So then this will make copies of 100 cross 2. Then the suppression will happen. Okay, either way you can go. So if you apply this function, this won't work because this operation will not take place. So what we can do, we can take the transpose here of x and then can find the distance. Okay, so now if you check the shape of this, if you check the shape of this, it will be 100 cross 1. So what is actually this? Every value here is denoting the distance of the point 0,5 from the every points in the data set. Okay, so this is the distance of the 0,5 from the very first point, something like that. So that's how you can find the distance of every data point from the point 0,5. Now what is your next task? You have to find the closest point. So you can call it some variable name. Let's call this distances. Okay, and so how you will find the closest point?
Get x of argument of distances.
Just min.
Yeah, exactly. So what you can do, you can actually, if you have to find the minimum distance, then you can use np.min of distances. It will give the minimum distance. So this is the minimum distance of the point. Okay, so but we have to find the which point has the minimum distance from that. So what we can do, we can find which at which point, which argument the minimum distance happens. So for that we have np.argument. Okay, so it will give you the index at which the minimum distance happens. So distance is, so at the 54 point is at the minimum distance. So we can take it out from the x, we can find out, or we can set np dot argument of distances. Right. So this is the point which is at the closest distance from 0,5. That you can also make sure that. So 0,5 was 0,5 was this point, and this blue point, this purple point will be at minus 0.10 and 4.999 something. So this is the closest point from 0,5, right? And this was we were getting here. This one minus 0.10 and 4.69 or this. So this is the actually the coordinate for that purple point. Clear? So that's how you can find the coordinate for in the closest point.
So what this argument does?
Argument actually gives you the index of the minimum of this in this array. So this is the array of the shape 100 cross 1. So it will check which value is the minimum. Okay, so index of that value will be returned by this function. Okay.
So in distances, it is a list, right?
Distances is a array, row vector you can say. Sorry, yeah, row vector.
So it automatically converts it into row vector. Like we don't specify. Like,
No. Here, what we are doing, new points and x, whatever these x and new point, these two are the NP arrays, n-dimensional arrays. So if you see this expression, distance function that we are returning, so here it is doing operations on two n-dimensional arrays. So obviously the output will be the n-dimensional array itself. Okay, and we are using the function distance. So the output of this you can suppose to be an array of itself, not a list. Okay, so if it is done, then we can move to the next part, next task. Now you have find the closest point. Okay, what happens in KNN? In KNN, we find the k nearest neighbors, and depending upon which are the in the neighborhood, which are of the majority class, and we predict that that new example belongs to that class, right? So for let's say k equal to 1, 3, all those values, you have to predict the label for the new point 0, 5. So how you will predict that? For that you have to write a function, and then you have to write a function definition as well, which is predict, which takes data set, the label, the new point, and the k value. Okay, and the function will predict the value for that new point for particular k, for that particular k.
Predict the new point means it will take the k nearest values, is it? And
K,
then
yeah, first it will find the k nearest values, k nearest distances, or k nearest data set, data points, and then we'll check which is of majority class.
okay, it's like finding the mode of the 5 things, is it? Something like that.
Mode of what? Yeah, mode. Yeah, exactly.
Okay.
Okay. So what is the logic for solving this?
So conceptually, you should just sort the distances and take the top 5, right?
Yeah, exactly. So we have already found the distances. We have to sort those distances. So what is the function for that? We can use np dot sort, right? So it will give the sorted distances. So this you can see these are all sorted distance, but we are actually we are not interested in these values. We are interested in the indexes of these sorted values, right? So we can find out the np dot arc sort. So this is where your that sorted distances are placed. So first nearest point is placed at 54th index, another is 73rd. So let me call this some variable indices. Okay. Now we have to find the levels of those k nearest levels, k nearest neighbors, right? So we can call this. We are interested in the label, so we can call this labels equal to by is your label set, and what will be your indices, right? And how many we are interested in? Let's say we are interested in first 5. Okay, so we can start the loop here because we have to find for every k from belonging from 1 to 32. So for I in range, or you can say I in for having 1 to 32 with the step size of 2. Okay.
Sir, make their spaces.
Right? Up to which index? Up to ith index. Okay. So we have our labels. Then how we will predict?
Mode.
Let's say knn equal to np dot sum of labels. So what will the output of this particular function np dot sum of labels? It will be the count of class 1, right? Isn't it this knn will give the okay? Why I'm
Not getting that. Can you start from the for loop?
Yeah.
Okay. So actually we are sorting our distances, right? Our target is to find the k nearest neighbor. So which k data set, k data points which are at the nearest to 0,5, right? And distances, we have distances vector which has all the distances. So np arc sort what will do? It will give you the indexes of those nearest points. Okay.
So we're going.
What is that K?
So we're going like we're looking at first 1k neighbors, then we're looking at 3k neighbors.
Yeah.
Is
So
it like that?
k here is number of nearest neighbors.
So we are trying out different number of
For
neighbors.
each K, okay.
For each k we are finding this. Okay, so first we are finding for 1k. Let's do this for 1k only. Okay, so one label is we are finding, let's say 3k, 3 labels. Okay, so here we are finding 3 nm, 3 nearest neighbors. So here we will get the indexes of those points which are at nearest distance, and such 3 points we are finding. So labels we can find. Now we can find the np dot sum of labels. So it will give out of these 3 which are of class 1, because remember in the labels, because it is coming from the vector by, and by has entry 1 and 0, right? Class 1 and class 0. If you sum these values, so it will count how many are belonging to class 1, right? So if knn is greater than 1 minus knn, sorry, 3 minus knn, 3 are the total neighbors. So in this case, what will you predict? KNN is the count of class 1 examples. So what will be 3 minus KNN?
Count of class 0.
Class 0. So if the number of class 1 examples are greater than class 0 example, then what will you predict?
Class 1.
Class 1, right? Or otherwise you will predict class 0. So let's check what's happening here. What is found? Index 54 is out of 1 for X is 0 with size 2. Size 2. Okay, by I have defined as in this manner, right? So you have to rerun this code. This code. Okay, this code. This is okay. This should call this some different parameter name. Now we will move this part. Distance. Okay. Distance. Okay, now it should come. Yeah. So if we are using 3NN, then it will predict that example 0,5 belongs to class 1. So let's look at our data set. So our data set data point was somewhere around this. So if you find 3NN, then it may be that first closes this, second closes this, and third closes this, right? So obviously it will predict into the class yellow. So class yellow was 1. So I think our prediction is correct here. Okay, so for all such case, we have to find, so what we can do, we can start a loop for I in np dot arrange of starting from 1 to 32 with the step size of 2.
So I didn't understand this KNN, like from the like below labels, like I didn't understand that part KNN, and if KNN is greater than 3 minus KNN. Like why are we doing sum of labels?
Okay, so what are the entities in labels?
So it's the closest distance, like first 3.
Yeah, first 3 closest points, right? The labels of those points. And what are the labels? Labels are 1 and 0.
Yes, sir.
So 1 means that example belongs to class 1, and 0 that example belongs to class 0. So if you sum those values, you will get the count of those example which belongs to class 1. Right? We are adding 1 plus 1. So if we are adding 1 plus, so we will get the counts of those example which belongs to class 1. So actually KNN is actually giving the count which belongs to class 1.
Yes, sir. And then what's this if KNN is greater than 3?
Okay, so how you predict? Let's say you have 3 examples, out of which 2 belongs to class 1 and 1 belongs to class 0. Then which example you will predict at new point?
Okay, right. Yeah.
Okay.
Sir, one situation is here.
Hmm.
So suppose that in this scenario, what's happening, that everything is coming either class 1 or class 0. So
Okay.
the two situation I found where that problem is happening, for example, for the k equal to 3, in the scenario k equal to 3,
Okay.
the first nearest is belongs to class 0.
Hmm.
And the second was is belonging to class 1.
Okay.
And in the third case, the third nearest is the class 1 and the class 0 is at the same distance.
Okay.
So what will be in that scenario? Because
that kind of scenario we randomly choose. It's not there any rule to choose any of these two because both are at the same distance, right? So we randomly choose those. So in the NumPy, what it will do, it will collect the first example.
Okay, so whatever the thing will come, it will choose by that, no?
By randomly we assign any of these two.
Okay, and suppose this question is there in that
Exam.
No, in the objective question, and the situation is given as the point.
Again, you have to choose randomly. So if such happens in the assignments or example, then there should be some clearly mentioned which one to choose. If it's not, then there's some ambiguity in that part, obviously,
And
because it's just randomly chosen, right?
One option is there that is can't predict. Suppose it is the objective option. One is the class 0, class 1, and third option is that we can't do.
No, actually prediction can be made, but just random prediction is made. It's not like we cannot predict. Okay, in the case of KNN, what we can do, if such a situation arise, we can add K to at different value. If K equal to 3 we are using, then we can increase K by 1 value or we can decrease K by 1 value. Okay, so that problem may be solved by using this. Okay.
Okay, sir. So one problem was K equal to 3, and same was that K equal to even. Means K equal to 4 or K equal to even, where all the first two is that in the class 0 and the second two is the class 1. Means the neighbor is distributed like that. We got the 2 in the 0 and 2 is in 1. Suppose for the even K. So in that case, if I'm doing the program, then it will be work. Okay, I can randomly choose one of them.
Yeah, either randomly choose one, or you can do just increase value of K by 1. So you are finding 4NN, rather than finding 4NN, you just go for 5NN.
Okay, so so the two problem was there in that one assignment question was there. I used this method and there was a fix. K was equal to fixed.
Okay.
And answer was
which question is that?
Assignment question that big 7 1 and 2 question something 2 3.
Assignment, you mean the graded assignment?
No, that practice assignment.
Okay, question number 1 and okay, I will check that question. And
Okay.
if there is any such ambiguity, I will try to remove that. Okay.
Okay. So both question was there and both has some contradiction was coming.
Okay,
so
okay, I will look into that.
Okay, and second was there that sir has written the program in the last tutorial the taught about the programming. So is it possible to after this you can go one look up on that?
KN and Cola file.
Correct, because that
yeah. I will go through that Cola file as well.
Okay, sir.
Okay. So what do you think will be the output here? Right? Okay, 1 1 1 1. That is wrong. Okay, here we have set 3. Here we have to set I. Right? So
in second line in the low cost.
Now it makes sense. If you use 1NN, so if you use 1NN here, so it may be purple. If you 2NN, 3NN, sorry, then it will be yellow. So along with this value, if you change value of K, the prediction may change, right? So that's what happening here. So for 1NN, the prediction is class 0. For 2NN, 3NN, 5NN, 7NN, prediction is 1. And then prediction 0, then 1, 0, then 1, right? So this area you can say that very ambiguous kind of region here. Okay, so how to choose K, that we will again see, because for different value of K, this part may give that decision boundary will be very it's not gonna be smooth for less value K, and for higher value of K, that decision boundary maybe overfit, right? So, sorry, underfit for high value of K. Okay, so this part is still. So this part is clear how we are making prediction, right? So we have to write the function for this now. So let's.
Sir, this will not handle more than 2 classes, right?
No. Because we have defined distance in such manner. Here we have set the point in the distance. Here we have defined the distance function. Okay, here, okay, x1 minus x2. We can do here as well.
You can,
Yeah,
I think
you
you can
can,
use
up
mode
to-
instead of that distance. In manual check, you can use mode. Then I
Yeah,
think
yeah. So that you can apply mode as well. That will also work. So scipy.stat has a function called mode. That function you can also apply here. Okay, so let's define that function now. So predict takes the data set, label, vector, how many nearest point you are calculating up, and for which you are making the prediction. Let's call this new point. Right now you have to find the function here. So how you will define that function? So first make sure that new point is in the shape of reshape. You can reshape into comma minus one. Right. So first we have to calculate the distances. So distances will be I will make use of the function distance. So distance of what? It takes new point, right? New point. Then x transpose. So that we have already done. Okay. So how many nearest point we have to find? K nearest points, right? So what we can do? We can call it K nearest indices. To NP dot R many of distances. Right? We are interested in by, so we can call this labels equal to distances given by. We need not to write the K nearest nearest K nearest indices in how many? We are interested in K, right? So if okay, first we have to find the sum, so we can call this sum K and this we can NP dot sum. Now if sum K and N is greater than K by 2, right? Greater than half of K. Right? So in this case, what will be the prediction? Class 1, right? Otherwise, then class 0. Is this fine? Let's check this. 20% x, 1 and then you find this point, right? So what is the prediction? It should give invalid index to scalar variable. Why this happening?
Sir, I think you took arg min, arg sort, it should be right.
Okay, yeah. Okay, so for 1 and n, this point was this difference.
So why did you do k divided by 2?
So KNN are so this sum KNN are the actually count of that count of class 1 examples, right? And so if they are greater than half of those examples,
Okay.
okay, so we'll return 1 and if 0. So remember here for 1 it was class 0. Class 0 for class k equal to 3 it was predicted to be class 1. class 1, 4, 5, 7, 6, 5, 7, also class 1. Yeah, so this function is working fine now, right? So any problem in this function? Okay, so we can move to the next part now. Now we have to find the decision boundary for k equal to 1, k equal to 3, k equal to 5, and we can also define the function draw decision boundary with the parameters data set, labels, and the k value. Okay, so this is going to be interesting part. So do this. Make use of the library matplotlib. It may take some time, so take your time and try to find out the decision boundary. So any idea how you will do this? Okay, so let's discuss this part. So any idea how you will go for this? Okay, so so whatever you have done here, you can post in the chat box. Do you have the session for MLP as well at 8 o'clock?
Yes, sir. MLP projects.
Project, right? You will be attending this, right?
Yes, sir.
Okay, so let's finish this part quickly. Then you can attend the MLP session. So how you will go for this? What is the idea for this? Okay, so first, what I mean by decision boundary, actually, we have to divide this region into two different colors. I mean, two different parts, one for the yellow class and another for the purple class. So what I will do, I will create an coordinate system, this coordinate system. So I mean, I will create a mass grid, and I will take thousands of all the points in the mass grid, and will predict the values for different values of k, right? And according to that, I will color those points. That's how I can get to different regions. Okay, so that is the idea for that. So how you will create the mass grid here? Yeah, PLD.mass grid. So for that, you have to define first axis, right? So I can set the minimum values for axis x1 minimum and x1. Okay, so x2 minimum. So this I can set as np dot min of what? X along the axis 0, right? So these are my minimum values, and I can set the maximum values of max and x2 max. For setting the axis, right? I can find this of x with along the axis. It is 0. Okay, to make sure that we can extend our axis by width, so we can subtract this 2 plus minus 2, and we can add plus 2 to here. So these are my axis points, last point. So x1 minimum to x1 maximum, and for y-axis we have x2 minimum to x2 maximum. Now we can generate points for our data set. So let's say x's are what np dot lane space. So we are generating the points for x-axis.
Sir, I couldn't understand the minus 2 and plus 2 part. Sir, could you please explain, sir?
Here I'm just extending my axis. So let's say my axes are starting from -3 to 3, just to extend to -5 to 5. I just subtracted minimum value of x minimum, and just to make sure that those points doesn't come on the boundary, last boundary.
Okay, sir.
Okay, I just subtracted -2 plus 2, just extended my axis by bit, by factor 2.
Okay, sir.
Why only by 2?
You can set any. You can set 3, whatever you choose.
Should it like start from origin?
No, axis will be start from origin, but from so minus x minimum to x maximum, right? It will go from x minimum to x maximum. My axis will go from x minimum to x maximum. I will just extend this because x minimum and x2 minimum are my data points. So to make sure that data point doesn't come on the boundary, I just extended my axis, something like that. So here my x minimum is, let's say this is my x minimum and this is my x maximum, right? So this doesn't come on the boundary. I just extended my axis by some factor, -2 here and +2 here.
Miss, it is just a factor of safety.
Yeah, yeah. Okay. Okay, so now, yes.
No, sir. I was thinking about the outliers. So, means outliers will be covered in the mean and max.
No, these are not. I just extending my axis. If you don't do that, what will happen? Those data. If you don't do that, what will happen? That data points will be on the boundary. Okay, so that will not look good. So make sure that it doesn't happen. I just added some factor here.
Okay.
And so same numbers will be added or subtracted, or this can be different.
Anything. Doesn't matter. Okay, so now I am set the points for x-axis. I can set 100 points so that I can predict the goal is for those 100 points, and similarly for y as well. So I can set from x1 minimum. So all those points between x1 minimum to x1 maximum, and how many points? 100 points I want. Okay, similarly I can do for y-axis as well, and then can start the grid. This will be x2 and 100 points. Okay. Now I will create the my mesh grid. So let's call it txs and tyy. So what is this? This is plt dot mesh grid. Sorry, not plt dot mesh grid. MLT dot mesh grid. With x-axis and y. Okay. So what is mesh grid? Now look at what is txs. Okay. So can you think what are those points? So these are the points on x-axis. These are the points on the line which is parallel to x-axis. So this will create the x coordinate for the coordinate system, and t by y will create will take the y coordinate of those points, right? All those points. Now what we can do, we can flatten those. Okay, so why we are doing this? This will be clear now. This will be clear in the next part. Just to figure out all the points, right? So these are my all the x coordinate, and these are all my y coordinates, and similarly x coordinate will be shared. So what we can do, we can make the grid points. What are my grid points? Grid point are actually what the column concatenations of these things, right? So I can make p dot column concatenate column stack. So what to do? What will be here? Okay, so I can call this txs and t by y.
Sir, what is flattening?
Flattening means before it was 100 cross 1, right? Sorry, 100 cross 100, 100 cross 100. Now flatten will make it in the row vector, and the same thing will happen from the y-axis as well. So all those coordinates will come into the row vector. It's not clear. Just let me show what actually happens there. By the diagram here. So actually what's happening here, so create. So let's say these are your 10 points. Here I have generated 100 points. Let's say 10 points on x and 10 points on y. I've generated 100 of those. Okay, so what's happening, and in t, whenever you create the mesh grid in the t-axis, it takes all the x coordinates. So x coordinate of this x, so let's say 1 2 3 4 5 6, these are the coordinates 1 2 3 4 5. So this will take the coordinate of this axis, then 1 2 3 4 5 6, and so next it will take the coordinate of again this axis, this line. Okay, so 1 2 3 4 5 6. So x coordinate of this line, x coordinate of this line, this line, this line. So all those points will be taken in here, and in t by all the y coordinates. So again y coordinate will be what, 1 1. So y coordinate will be 1 1 on this line by coordinate. So on this line by coordinate will be 0 0 0. So 0 0 0 0 something, and for 1 1 1 1. So it will take all those by coordinates. So what I will do, I will flatten those. So what will flatten will do? It's 100 cross 100. In this case, is 10 cross 10. So it will take all the point in one row. So 1 2 3 4 5 6 1 2 3 4 5 6, and all the by coordinates. So 0 0 0 0 0 1 1 1 1 2 2 something. If we column concatenate we will column stack those, so all points will be taken, right? 1 0 2 0 3 0 4 0. So all those points will be taken in the grid points. Is that clear?
No, sir. Means if you don't flatten, means what is the problem? If you don't flatten, and what is the problem to solving?
No, there's no problem in that as well, but you have to write different code, your code in different manner. Okay. You need not to flatten as well, but just to make just to ease my computation, I just flatten those, and I just here grid point will be all such points. Now I have all such points. I will make the predictions on the coordinate system. Okay, so grid points are what? Grid points now are my all the points on the coordinate system. So
yeah, practically just aligning the points, stacking the points
aligning,
below
aligning,
X and Y.
That's it. Yeah, that's it. Okay, so if you check the grid point here, yes.
Yes, sir. So what will happen if I do something like that? So I need to draw a decision boundary, right? So what will happen? I can iterate through the entire. There is a one way. If I can iterate through the entire point on this dimension, and put that separate this particular point either in the class 1 and class 2. Using that way I can do, and little more optimization if I can do, then I will do one thing. The square dimension, I will draw a middle line, and I will use that some binary search type of operation. Means first I will see that middle one, at lying on the which class 1 or the class 2, and then I will go up or down to decide that. Yes, can you go here that in picture? Yes, so I will do one thing from that something like that 5 and 7.5.
No, actually point is that here the decision boundary need not to be plane surface.
No, I'm not telling the plane surface. It can be any randomly. So I can iterate the in the one dimension. For example, I will take that x-axis equal to 0, and I will iterate through the y-axis, and I will fix that point where it is the separated.
Yeah, exactly. That you can do that as well. And in that case, you need not to flatten your that TXS and TXY, and then you have to you can start loop and nested loop, right?
Correct, and that nested I can optimize through that binary search operation type of algorithm.
Yeah, exactly. You can do that as well. Okay,
but if you iterate to the y is equal to 0 or x is equal to 0, but sir, our partition line is in the 45 degree or certain angle.
No. Actually, they are what? So think what I'm doing here. I'm collecting all the points, and I will make the predictions. Okay. What he is saying that he will take first all those points which are let's say he is starting the loop for y-axis and then for axis. So he will take all the points which are along y equal to 0. Then he will take all the points which are along y equal to 1, something like that, right? So he will start his loop, and then nested loop. Okay, so first loop for what? All those points which are along the y equal to 0, right? And in the nested loop, it will iterate the x values. Okay, so let's say he is started for y in this range, and for x into this range. So for first iteration, it will take all those x values along that x equal to 0, and then we'll start again the same loop y equal to 1. Then all on the line by equal to 1, it will take all points from x-axis, right? That you want to say, right?
Yes, sir. Yes.
Yeah. So that manner you can also go. That is exactly fine. Absolutely fine.
Okay.
Okay. So that manner you can also go in. What I'm doing, I'm just collecting all those points first, and then we'll make the prediction.
Okay.
So here you'll have to column stack TXX and TY, right?
Yeah, because here it's on the x. Here it's a coordinate for x-axis, and this is coordinate for y-axis. I will just column stack those so such that they will become the points.
Yeah, and I think you just missed out TXX and TYY. You've written just XX and
Okay, sorry, yeah, exactly right. So it is TXX and TYY. Yeah. So now we have points. Now I will make the predictions. Okay, so let's say grid prediction. Grid. So I have to start the loop because every point I have to find the distance. So for I in range. How many points? So length of. Okay, so I can call it grid points. Save 0, right? So grid predictions I will make. So I have to start. I have to actually store these predictions. So I can start a 0 matrix here. Predictions equal to np dot zeros like what? Either like txx, right? And now I can store those predictions. So I can make use of the function predict. Here, what is my data? Here it is xx. Here it's x data, y data, k value. Let's say k value is 1, and the new point. So what will be the new point? I will take all those grid points. Grid points. Which point here I will take? I will take the ith point. So does this two lines make sense now? I am making predictions for every point in this grid point. So in grid points, it takes all those points. Now I will make predictions for all such points, right? Is it fine now? Now I can plot the scatter plot. Plot dot scatter. So what I will plot? I will plot t not txs. I will plot on the x-axis. I will plot xx, on the y-axis I will plot y, and the color I will use according to grid prediction. Grid predictions. Right. Okay. Okay, this is gonna be txx. Txx of t by y. What is going on here? It should be xx, right? Xx and y only, right?
Excuse me, sir. May I add something?
Yes, sure.
So the predict function is actually returning a scalar, right?
Scalar, but I'm every time I'm just.
Yeah. So the grid predictions, I think we can't directly assign it like that. I believe.
No, I cannot.
So I think we need to loop for the predictions array as well. That's what I believe, but I'm not sure.
No, I'm
Because-
taking only 1 point at a time. I'm taking 1 point at a time and making predictions. I'm storing there.
That's right, sir. But is it possible to directly equate it to that scalar? Because this is an array, I believe. That grid predictions.
Mhm.
And
Okay,
and
you are saying
the
here, right?
yeah, exactly. So the right hand side is a scalar. So like that, I think.
So it is saying X should be T. Okay, now it's working fine. I can set alpha equal to 0.2. Okay, so this is gonna make decision number. I can plot my points as well. Scatter. Now point will be what? X. X of alpha points to 0 column. And alpha points. First column. C equal to 1. Right? So here I can set alpha equal to 1 and can set what else? That should be fine. Okay, color map I can also use size also I can set 200 and I can also use figure size, right? EFT dot figure size equal to let's say it. Okay. Okay. C map I can use as this. This is looking fine. So does it make sense now? So any doubt here?
Sir, but the decision boundary is means it has some kind of islands also. Means
Yeah, because I'm using 1 NN here. K I've set 1, right? K I've set 1 here. If I set K equal to let's say 2, let's say some higher value, let's say 1, then this island can will not be there. Now much more smooth boundary, right? Why this is white here?
okay, got it, sir. As we increase the number K, it will be smoothened.
Yeah.
So what is
But the error will increase in the a higher number of K.
The test in the case training error will be higher. If you set K equal to high value, then the training error will be higher.
Yes.
Right.
So, sir, what should we choose? Means ki smooth line.
Yeah. So that is our next part. So before going to that, I can define next function as well. Draw decision boundary that I'm to do. So I can go through the code. Okay, so this is all done. Yeah. So same kind of thing I will do here. But in general, I will set K here. So this function take X by K. I will set my axis limits X minimum to X maximum. Similarly, I can take points on X axis, Y axis, and then I can start mesh grid. To get the points, all those points I can flatten those and then can column stack. So that's I get all those points here grid point will contain all those points. Now I will make predictions. Okay, so grid predictions is actually I will start a zero array. Then I will for every points. Okay, right. So for every points I will make the prediction and will store in this at the ith index. Okay, ith entry. Now once I make the predictions, I can check. I can actually make the scatter plot of txs t by y using grid prediction and alpha. I've
What
set
is that
0.1.
C equal to grid prediction?
Grid predictions. So remember here we have set C equal to by. So all those points which belongs to class 1 will be colored from one color, and which belongs to class 0 which belongs to colored with some different color, right? So for predictions also we will now we are making predictions for all txs and t by y, right? All those points. So all those points I will color those points which belongs to class 1 with some color, and which belongs to class 0 with some other color, right? So it will give me my two different regions, one for class 1 and class 0. So different color for class 1 and different color for class 0.
So
Okay.
what do we do?
So based on the values of grid prediction vector, it will take assign how much ever color it needed.
Yeah. So remember we have taken lots of points. I think 10,000 points we have taken on those axes. So it will predict it will make predictions for all such 10,000 points, and then we'll color those points. In that way we can color our region, our space into two parts, right?
Okay. And what is that C map?
CMap actually it's color combinations for those, right? So different values it takes. Where it is blues, I don't remember many, but for different combinations of color we can use that CMap.
Okay.
Okay. So
So
let's.
what does K represent?
Sorry.
K.
I didn't get point. What
does like K represent here? Like,
K nearest neighbor. How many nearest neighbor we are finding?
so when we increase it, why does the graph become smoother?
Okay, so let's look at k equal to 1 first. Where is that? Right. So if you set k equal to 1 here, so it will check k nearest neighbor, right? So it will check only one nearest neighbor. So if in this area, if we so in this particular area, if we make predictions, so one nearest neighbor will be purple color. So that purple color will be region Y, right? So if we go here in this particular region, then in this check, it will check one nearest neighbor, and that one nearest neighbor will be purple color. So the prediction in this region will be purple. But when you go this region in this part, so one nearest neighbor will be what? Pink. So that region will be colored with black. Okay, so once we increase the value of k, then what will happen? If we increase the k value, let's say k value 7, then rather than looking for one nearest neighbor, it will look now 7 nearest neighbor, right? So in this again some different thing.
It's not alpha, right?
So I set alpha. Alpha is 0.1. So I have to set k, right? K is 7.
Alpha is 1, right?
Yeah, here it's 1.
And S equal to 100, what that is?
Size of those markers.
Size of the points, huh?
Yeah, points.
Okay.
Okay. So now for k equal to 7, look these regions. So before it was white, right? It was white because it was only choosing one nearest neighbor. Now it will choose 7 nearest neighbor. So if you choose 7 nearest neighbor, so the majority class will be pink, and the predictions for all such points here, which are present here, will be on the class 1. So the color will be black, right?
But so where your pointer is the purple color. So here
Yes,
the 7 nearest will be the yellow one. No?
7, we are finding 7 nearest neighbors, not one nearest neighbor. In case of one NN, it will only prediction will be white. But we are now finding 7 nearest neighbor, and then we'll make predictions. So 7 nearest neighbors will be
for this purple point. Suppose if it is a new point.
Okay.
Then it should be yellow one, no?
Yeah, the prediction will be yellow, but the point itself, I'm not making it yellow. I'm just
Okay.
this is my data set.
These are the original points.
Original data set. Yeah.
So it will be counted as error.
Yeah. So this is misclassified actually.
Okay.
For 7 and N, this point was misclassified.
Okay. Got it, sir.
Okay. So if you keep on increasing your K value, surface may be smoother, and if you increase higher, then that may underfit. Okay. So that's how this function is working. We have already passed 8. We have one more task to find. Now we will find the accuracy. So I can explain this part quickly, and then we can close this. Okay, we have 2 more tasks. Okay, so here, what is your task number 6? We have to divide our data set into training data set and validation or test data set, and then we have to find the evaluation. So evaluation means we have to find the accuracy. So it was easy part. So here I can split my data set into xtrain, xstate, bytrain, bytest by using the module called sklearn.model selections and the API test train split. Okay, this have you already seen. Now, if I define evaluation part, so evaluation, it will check whether prediction is correct or not. So here I will start a vector np.0 vector. Then I will check the in all such. I will make the predictions for x. X now x here is my test data set. Okay, so yeah, so new point will be coming from the data test data set, and the training data set is x and y. So it will check the distance from x training data set and will make the prediction for that new points. Okay, so all such test data set, I will make the predictions and I will store those predictions into bypredict. Okay, so for finding the accuracy, what I will check how many are correctly predicted. So bytest was actually my actual labels, and bypredict are the predicted labels. So I will check whether they are correctly classified or not. And by finding mean, I will just take total correctly classified point upon total number of points. So in that way, I can find the actually this is not error, this is accuracy.
Won't it be 1?
Sorry.
Mean.
Mean actually we have found accuracy. So accuracy is what? Total number of correctly classified point upon total points, right?
Okay.
So bytest equal bypredict is all those points which are actually correctly classified, and if you find mean, then it is actually the accuracy. So it should be accuracy, not error. We'd call it ACC. Okay, so this function is clear. This is pretty easy part, right? So if you find the accuracy for 2 and n, and for xstate bystate, the accuracy is coming out to be 0.75. Okay, so if you go higher value for, let's say, 7 value, your accuracy is coming out very high, 0.9. So maybe high value you can choose for k here. K equal to 9 will give you 0.95 accuracy. So 9 is, I think, the best value for k here. So how to find the best value of k? You can plot accuracy versus what? K value, right? So here I have plot k value versus error. So for different value of k, I have chosen k value from 0 to 16. Okay, so for every k value, I will find the evolution. I will find the accuracy. I will plot those accuracy versus k. So this is my k value, and this is my accuracy value. So the plot will come something like that. It is if I choose k value equal to 1, my accuracy will be 0.75. If I choose k equal to 2, my accuracy will be 0.75. If I choose k equal to 9, my accuracy will be 0.95, right? So what is the best value of k here?
9.
9, right? Because we have the highest accuracy for k equal to 9. So by looking at this curve, I can find out my best value for k. Is that clear?
Yes, sir. Yes.
Okay. Okay, so this is all for Solve with Us instructor session. Should I go to the Colab that Sir has used in this? Most of the part I have already covered. So this whole thing is already been covered here. Only part which is remained is regression part.
There is one doubt I have.
Okay.
If there are 2 points at the same distance, like 2 different classes at the same distance, then how
Okay.
which class?
Sorry, if 2 points are at the same distance.
Yes, so from class 1 and class 2, they are at same distance.
Yeah, so you can choose randomly out of these.
And there is a question in graded assignment, like then how to answer that?
Yeah, then there will be some ambiguity in that part, in that question. So it should be mentioned which randomly what you are speaking with, because if you are
Or I can select cannot be determined.
Huh?
I think one question has marked as 0 in graded. So I think this is that one.
Yeah, so there is an option for like cannot be determined. So is that a safe option?
Okay, so which question is this? Question number 2 of graded assignment, is it?
It's question number 2, yes.
Okay, okay. I will look into this. I will look at that questions. I think someone has already mentioned this part.
Okay.
What is the purpose of C equal to Y? To set two different colors according to Y, right? So we have data set. We have 100 points. Now, if you want set C equal to Y, then all those points will be colored with only one color. Now I need to color those to differentiate between two classes. I will separately color those with two different colors. So how to choose that color? We can set C equal to Y. So color will be chosen as Y, values of Y. So those points which belong to class 1 will be colored with pink color, let's say yellow color, and another which belongs to class 0 will be colored with different color. Class here it was purple, right? So to differentiate those, I can choose color. So C stands for color, and how to choose values? We can set as Y, depending upon values in Y.
Sir, to draw the decision boundary, there is no use in the finding the prediction. It's just for that visualization only, no?
Yeah, it's visualization. So for different values of K, you can find different decision boundary, and looking at the curve, which is more smoother, which gives less error. By visualizing this thing, you can also look at the best value for K. But in this case, you have to find a different chart, right, for different K. So rather than looking at different charts, different graphs, you can find the error rate. So you can find the graph for error versus K, or accuracy versus K.
So loss and the accuracy also we can do the programmatic.
Yeah, accuracy. So we have done accuracy versus K, right? You can also do loss versus K. Loss means how many misclassified points are there.
Correct.
Okay, so that also you can do. So less value for error, you will set that K.
So one more thing here was discussed, entire session was on the 2 type of classes. But in the reality, it can be the number of classes.
Yeah. So this notion can be extended to any number of classes.
Okay. So after some time, the visualization is not possible also.
No, features. I'm taking only 2 features. Then all will go into 2-dimensional space. But if you increase your number of classes, then that will be more compact visualization graph. So here we have only 100 examples and with 2 features. But you have more than 2 features, then it will go to 3 dimension, 4 dimension, and all. That visualization is not possible.
Yes, correct.
Right? So I think you all should join that meeting, MLT meeting, that project meeting, if you are in MLP side. That will be helpful for you. So I think we should drop off now. You can go through that collab, KNN collab file. That sir have used. That is not difficult. Most of the part we have already covered here. Same kind of code or same kind of idea is there. Okay, in different manner they can be executed, but the same idea is used. Okay, and regression problem is just how to make prediction. Here we are using majority class. In the case of regression, we will just simply find the mean of the labels. That's it.
So can you share the collab file in the chat box
Which collab file? This,
today that we did?
can I do this? Okay. I don't know whether just you can share it or not. Let me check. Okay, so I'm sharing this, but try this one. Okay, so let me make sure it is only only viewers. Which collab file I did share?
So the from week 1 to week 6, all those collab files, like, are they uploaded on the dashboard?
No. Collab file we are not sharing. Oh, I shared the wrong collab file.
Yes, sir.
Try this one. Can you access it now?
Yes, sir.
Last one I have restricted because I cannot share that collab file. Okay, so I think we should drop up now.
Thank you so much for the session.
Thank you everyone for joining.
Thank you, sir.